Hello. So now we will study the angle of contact. This topic we study under the head of surface tension. So what happens when the liquid is in contact with some surface? This is my surface, this is a vessel's surface, vertical surface, and if this is a liquid layer. So if the liquid is in contact with vessel surface, the particles onto the surface of the liquid, they experience different types of forces. What kind of forces they experience? They are the same kind of forces but are coming because of different types of particle. So this particle here, which is onto the surface, liquid surface, it will experience force in two different directions. So one force it will experience in this direction, in upward direction. This is the force which is coming because of the particles or the atoms of the vessel. So atoms of the vessel will try to pull this particle up. So these atoms will try to pull this particle up, and the force applied by these particles onto the liquid surface, or the particles onto the liquid surface, is known as adhesive force, FAD I am writing. And there are particles below the liquid, they will apply the cohesive force, COH. So this particle onto the liquid surface is experiencing two types of force. One, because of the different types of particle which are there onto the vessel's surface, and the second are due to the particles which are similar to this particle but below the liquid surface. So these particles will try to bring this particle down, and this force will try to bring this particle up. Depending upon the net resultant of these two forces, adhesive forces and the cohesive forces, depending upon the net resultant of these two forces, the particle might move up or down, depending upon the resultant of these two forces. Now, if the adhesive forces are more than the cohesive force, this particle near to the surface of the vessel, they will move up, and they'll tend to make that kind of shape. They'll tend to make this kind of shape. This will be a spherical shape for which the center will lie on to the upper side. In this case, F adhesive will be more than the F cohesive. And when cohesive force is more than the adhesive force, these particles onto the surface, they will go down. They will go down, and they'll again make a spherical surface, but this time the center will be onto the below to the surface. You see, so this case, when the net force is same, when the net force will be same, which is a hypothetical case which never happens. So in this case, the surface will remain flat. Okay. So you see, in this case, what we will do, we will define an angle. Ultimately, the liquid surface is going to make some angle with the vessel surface. So the liquid surface is going to make some angle with the vessel surface, and this angle we are going to define as theta c. This is defined as angle of contact. The value of angle of contact will depend upon whether this F adhesive is more than cohesive or it is less than the cohesive force. Okay. So in some cases, this theta c will vary from 0 to 90, like in this case. In some cases, the theta c will vary from 90 to 180, and in some cases, theta c will be equals to 90. Okay. So one by one we'll study this. So first we'll study this. So when the adhesive force is more than cohesive force, in that case, angle of contact theta c will be more than 0 but less than pi by 2. Okay. When the adhesive force is more than cohesive force. In this case, center will lie onto the air side or upper side of the surface, and liquid will rise. In this case, liquid will rise. Why it will rise, we will see. The second case, in the second case, theta c will be equals to pi by 2, and in this case, liquid will not rise, it will remain stagnated at the same point. So, will not rise, or it will remain same. Remain same. And the third case, in this case, theta c will be more than pi by 2, but it will be less than pi. And in this case, what will happen? The liquid surface will go below the previous surface. Liquid surface will go down. Okay. As far as the example of this surface is, this case is concerned, when the example of this is glass water combination. So when the liquid is water and the vessel is glass, in that case the angle theta c, angle of contact is in this range, and liquid rises in that case. There is no such example for this case. No such example exists for this case. Hypothetically, some people talk about having a ice vessel and the water as a liquid, hypothetically, which is not true, which is not possible. Even in that case, the theta c will not be 90. Okay. This case, when the theta c is more than 90 but less than pi, in which case the liquid is going down. The example of that is glass mercury, we call it Hg, mercury combination, when the walls are made of the glass and the liquid is of the mercury. In that case, liquid will go down and the angle theta c, value of angle theta c is less than pi but more than pi by 2. So you see this value of theta c, which is the angle of contact, this theta c is like a constant. The value of this theta c depends upon the material properties or internal properties of liquid and vessel. So basically it depends what kind of vessel you are using and what kind of liquid you are using. It does not depend upon the external properties. Theta c does not depend upon the external properties. If anything will change the internal properties like the temperature and all, if anything will change the internal properties of the liquid or vessel, the theta c will be changing. So theta c will depend upon what kind of liquid you are using and what kind of vessel it is there. Okay, it does not depend upon the external property. So whenever the examiner gives you one combination of liquid and vessel, the theta c, the angle of contact, is generally constant. It is generally given to you. Okay, and which we can use in the further formulas. Okay, so here we have seen the angle of contact, how to calculate that, what does it mean by angle of contact and why we need it. Angle of contact is something which provides us the internal properties of a liquid and the glass combination, and based upon that we can calculate how much rise of liquid will be happening inside the capillary or how much fall will be happening for the liquid inside the capillary. Okay.